Bismillahirrahmanirrahim. Uh, in this session, we will learn about the small increments and approximate values. Uh, this topic is taken from additional mathematics course for IGCSE and O level exams. So this is basically this is a curve, and this curve we have taken an incremental change. So if some values have some incremental change in the one direction, then it has some impact on the other parameters. So suppose that this is x and y, and a small incremental change in x is delta x, and similarly the incremental change is delta y. So we will move from this point P to point Q with this small value. So we will cover this kind of problems in exercise 12.6. So here is exercise 12.6. Suppose the variable x and y are connected by the equation this. So y is dependent on x, and find the approximate change in y as x increases from 2 to 2.01. So the delta x is 0.01 because this is x and this is x plus delta x. So the delta x is 0.01. So we will see this problem. So this is problem number 1, where we have this y is equal to this one, and x plus delta x is equal to 2.01. So we have to find the delta y. So this we first differentiate it. Dy by dx is equal to 6x square minus 3, and when x is equal to 2, we get the value dy by dx is equal to 21. So this is 4, 6 are 24, minus 3, 21, and using this relation delta x by delta x, delta y by delta x is equal to dy by dx, and then this dy by dx, we know that this dy by dx is equal to, at this point x equal to is 21. So this is 21. So delta y is here and delta x is 0.01. We know that the difference of x and x plus delta x is 0.01. So this is 0.01. So I'll multiply this, we get this delta y is equal to 0.01. This was our point. So similarly for problem number say problem 4. Let's go to problem number 4. So let's move to problem number 4. Here we have y is equal to 1 over 3 x minus 2 whole power 6. So here we have a change from x to under root x p. So this is basically, let's see the problem again. Find the variable x and y are connected by the equation this. Find in terms of p the approximate change in y as x increases from 9 to 9p. So the incremental change is p, very small, change in y as x increases from 9 to 9 plus p. So this is this is delta p. This is delta p, and x to delta p, delta x, x plus delta x is equal to x to 9 plus p. So we will take the differential of this one. So this is 6, 1 over 3x minus 2, and then this one is 1 over 3. So we get this value dy by dx is equal to 3 to the 6 to 1 over 3x minus 2 power 5. At x is equal to 9, the value of dy by dx is at place value 9 here. So we have dy by dx is equal. Now we have an incremental change is p, because 9 plus p, this, so this p is an incremental change in x. So the incremental change in y is equal to delta 2p. So this is the value required. Now moves to problem number 7. So this is basically t is equal to 2 pi under root L upon 10. So this is G basically. This is simple pendulum equations. You also use in book of physics. So we take this length is incremental from L to delta L, and the length was initially the 40 units and it increased to 41. So this is 40 plus 1. So this is 40 plus 1. This is 41 is basically this is 40 and plus 1 is 41. So this is typing error. This is 40. So we have to find this dt by dl is equal to 2 pi over under root 2 this, and then L is above, so it will comes in the denominator with this 2. So we take this derivative. We know that how to differentiate it. So I calculated this like this, and placing this value L at this place. So L was initially 40. So at this value, this is dt by dl is equal to pi by 20. So this delta t by delta L is equal to dt by dl. So at this delta L, we can place this value 1 because it is incrementing from 40 to 41. So this delta t is basically this pi by 20. So this is the required change in time period with the change in length of the pendulum. Now move to problem number 8. So this is the volume of a solid cuboid is 360 centimeter cube and the surface area is a centimeter square. Express y in terms of x. So we have to express y in terms of x. So this is simply the multiplications. So we will see this how it will show. So this is the volume. So when we multiply all these, we get the volume, and the volume is given as 360, and we can rearrange with respect to the y to get the equation. So easy. And then surface area, you know, this is 6 areas are there. The top, bottom, both two sides, one front, one back. So we'll get this one. Similarly for the last one. So let's find the terms. Find in terms of P the approximate change in surface area as x increases from 2 to 2 plus P, the small change. Whether the change is an increase or a decrease. So we will see this, whether the change will increase or decrease. So let's move to most desirable problem. So this is basically 2x, x and y is basically the volume of the system, length, breadth and height. So this is 2x square, y is equal to 360 centimeter cube. So the y is equal to 360 by 2x square. So this is 180 by x square. Now surface area. So this area is the bottom area. Similarly, this is the top area. So for this, x and y is the side area. So the other side is also x and y. Similarly, for the front, this is 2x and y. This is the front side and the back side as well. So each multiplied by 2. So this is the area of the bottom and top. So this is 2. Bottom and top. This is x and y, basically the sides, left or right, and similarly this is front and back. So all surface area, the 6 surface area, 2 times this, 2 times this and 2 times this. So 6 surface areas are there. So area is basically this. Now A is equal to this 4x square plus 4xy plus 2xy is 6xy. So 6xy, in place of y we can place this value 180 by x square. So at this y, we can place this 180 by x square, so it becomes 1080 by x. So this is the value that has to proved. This has to show. The surface area has appeared as this. So it's proved in the part C. We have taken this x is for this. We have to find the incremental change in area with the increase in x. So as x is increasing from x to delta xp, then this x is basically 2, and 2 is increasing from 2 to 2 plus p. So this dx by dx is obtained as 8x. This is 8x, and this is this goes up and then minus here 180 and then x square, and we apply this 2 here, so 2 square, this is 4, and divide and we get this minus 254. So dA by dx is equal to minus 254. So in place of this x we have placed this 2 here, 2 square, this is 2, so 2 square, so we get this value, and then this dA by dx is equal to, we can write this like this, so delta A upon delta x is equal to dA by dx. Now this delta x is small change from 2 to 2 plus p, so this is p, small p, so this is d254 at x value 2, so we'll place this 254 here and multiply, and delta A is obtained as this. So this is negative change. The surface area has decreased. So this is all from 12.7, 12.6. Now in the next session we will discuss the rate of change, more challenging problem.